Uh, so we would look at the strategies and understanding the data. From there, we would move into looking at the real analysis of the data. What we'll be doing subsequently is we'll pick various themes per the course outline, and then we would share so that you see how the data goes. Again, please and please, it's important you understand these things because you will need them. Remember, the exams is going to be practical and then written. So you need to understand the practicals aspect of it. And not only generating, but the implication and the intuition. Okay, so let's quickly move on. From the onset, you've been looking at predictive, descriptive. Last week, we ended with most of the descriptive analysis. So today we're going to start with predictive. The word here is predictive, so it means we are going to predict. Right, the key word is predictive, so we are going to predict. Here we are moving from basic descriptive analysis to more of advanced analytical techniques. So at the end of this outline, we have to look at the different statistical tests for predictive. We'll provide insight into setting the right test based on our data and our data type, and then we'll uncover trends, predict future outcomes. Right. So, ladies and gentlemen, that's what we set for ourselves, and we pray we can finish it, and then we'll move to the practicals. We'll also look at the application, and then we'll look at the software, of course, focus on. Now, we titled this from descriptive report to predictive report. Why? Because basically all that we do is 30% of the people in the organization have masters, 30% are male, 40%. What does I mean? We have to move away from these things to leveraging HR data to make it more effectively and efficient. We also have to break that barrier so that we'll contribute to knowledge, because the current limitation is that we don't give insight into the data. Then the human metrics is also very important. Remember, our descriptive statistics is just a snapshot. How many are male? How many are female? What does that mean? How would the organization benefit with that? So we have to move beyond that, because remember, even a recruitment data, just so many things. For example, if I have a recruitment data, which I'll share some of them, the time of hiring can be there, the hiring cost is there, the recruiter's productivity, a lot of informations are there. So we need to move beyond that to looking at various analysis. Now, just a minute. I have an intruder. For example, in the workforce data, right, you have age, gender, tenure. It can be head count or name, but we need to move away from this, right? We need to move away from this to a more predictive analytics. So that's what basically we'll be looking at. And these references are supposed to guide you a lot. And if you look at Besson, he makes certain arguments. and he highlights the importance of predictive analytics. And his argument is that it's a tool for understanding performance using historical data. If you look at Huselet, he also talks about it. So there is no need arguing about predictive data. We should move away from basically descriptive statistics to predictive analytics. And for the 2 weeks or 3 weeks remaining, we'll be doing a lot of the predictive analytics. We want to move beyond just reporting descriptive to looking at different regional differences. The role, are these significant? What can we do? So a key challenge in implementing predictive data is simply the case that what are we going to analyze? What are we going to analyze? Then the next thing we need to focus on is that if we know what we are going to analyze, what model or which model are we going to use? If we know which model we are going to use, it's a good start. What data do we have available? It's also a key. Now, we would apply most of the predictive analysis to look at talent turnover, team diversity, recruitment, selection, and induction. So what is that telling you? We are going to move away from simple descriptive reporting. 20% are male, no, to a more predictive analytics. And that predictive analytics is simply because we want what? Empower you as a professional from what we call a passive data observation to what we call a proactive workforce planning. Ladies and gentlemen, whilst trying to do that, you will hear me mention a lot of things. One of the key things is the keyword statistical significance. Let me be careful before I make some errors in pronunciation. Statistical significance. Why is this very important? Why is this very important? Now, it is important because it helps determine whether the results are significant. Now, the goal is to assess whether there is a meaningful observed pattern, or the patterns we see because of the analysis we are performing is due to chance. I repeat, we are doing statistical significant model because, just a minute, please give me just a minute.
Just to paraphrase a few things before Prof comes back, when we say we are using statistical significance in our analytical testing, we essentially want to move beyond the use of descriptive parameters such as mean, median, to actually ascertain whether the mean scores that we've seen as a basis of making a decision is actually statistically significant. So for instance, if we end up uncovering that the young guys in the organization in terms of their performance and contribution to organizational success, scoring higher means compared to the older folks. That is one way of drawing a conclusion, but that conclusion cannot be deemed as strong enough. So when we come to the use of statistical testing, then we are actually moving beyond the means, the median, the pie charts, and so on and so forth.
Okay, thank you, Dr.
Okay, Prof.
Yes, so we want to continue from where Dr. Augustine left off. We want to find out, assess, are the changes that we see due to observed patterns or they are due to chance? Females are performing better than males. Is it a pattern or it happens once in a while, or it's just chance? So we are looking at that. And if we want to look at the concept of statistical significance, then we have to test hypothesis. So if you've done research, which I know most of you have, you would have heard of research hypothesis. And then we have the null hypothesis. Usually the research hypothesis will suggest a specific effect of a relationship. Too much of maybe fatty food will give you cholesterol. The null hypothesis is saying there is no effect. So the research hypothesis is saying there is the effect, or too much of fat leads to cholesterol. The alternative hypothesis is saying no, such case. Now, the question is we need to test. So whereas if people are taking too much for fat and they are having cholesterol, does not mean that that is the case, right? All that it means is that there might be no effect. Right. Now, for us, we can have an example. Customer service training improve customer satisfaction score. That is a research hypothesis. The alternative hypothesis is saying training has no effect on customer satisfaction. To test this, ladies and gentlemen, we need to collect data. Remember, organizations do not base their decision based on descriptive statistics, mean, standard deviation, frequencies. No. That is not what organizations base their decision on. Car bank, GCB, maybe they are looking at performance. And then they conduct a study. Then you tell me that, oh, Car bank has a mean of maybe out of 10, they have a mean of 9.8. Then this bank, maybe GCB has a mean of 8.6. It means that customers are more satisfied with Car bank compared to GCB. It might not be the case. You are basing your decision on descriptive means. We don't use means to form policies within organization. We want to find out, is there a significant difference? And that is how we go about computing. Usually, you will also hear of the word confidence intervals and significant difference. Is there any difference? Yes, Jifa.
Good afternoon, Doc.
Afternoon.
Please, you would have to forgive my background a little. My lights are out and I needed to find a place to join the class.
No worries.
Yes, please. I wanted to ask a question on the the part that you mentioned that organizations do not base their decision making or policy making on descriptive. If you could
Yes.
kindly recap it again. I didn't
So
catch.
okay, let me go over. I'm saying that generally organizations do not base their decision on descriptive. For example, you go and then there's an index, and then I collect data and I say, oh, for performance, I collected the data from 2 banks. This is hypothetical, right? So it doesn't mean it's the actual. Maybe GCB and then Cowbank. And then I go and I say, okay, I'm looking at performance. And then customers rated the performance of GCB as maybe 8 point something, Cowbank as 9 point something. Is that to say that Cowbank are better off compared to GCB? That might not be the case, right? There is more to it. Why? Because the mean is just the average. But we want to find out, based on the performance, is there a difference? So that is why the word statistical significance is very important. Why? The difference that we see, is it significance or is it the pattern? So that we can read meaning into it, or this is just one-off thing. So the question is, if it is significant, then we can use it as a policy or policy base. If it is a one-off thing, then we can make policy meaning out of it. If it's one-off, then we just say, oh, it's one of those things that happen. But if it is something which is significant, we say, okay, we can make meaning out of it and we can use it to form policy. That's why we say that organizations do not really base their argument on just what we call it, means and standard deviations. No. I hope I've answered your question, please.
Yes, Doc. Halfway.
Okay, so let's move on. Now, again, you would hear if you read any document or any book in HR or something, you hear of the word, or a journal, before you hear of the word confidence interval. Usually, a confidence interval is just an interval at which that we are confident enough to say that, okay, there is some meaningful patterns for which we can make a recommendation. So the standard confidence interval is 95%. And I will repeat this. If you are going for a surgery, doctors will also perform this statistical test. And even if you are sick and you go and do a lab test, they always perform this test. And they use the standards. So you perform the test, the person in the lab will perform all the tests that he needs to. And then based on that, he can tell you whether there are what we call statistical significance. If he says, oh, yes, there is significance, and then you hear the doctor will tell you, oh, yes, you have significance plus virus in your distance. So if you do that, then he will tell you that, oh, there is significant parasite, then it means you have malaria. In fact, in the next slide, I'll tell you something that you need to know. You know, when we're doing COVID, you hear false positive, false negative. I think the next time when I'm doing that, I would explain that to you. Now, one of the things that we need to know is that 95% confidence interval is the same as 5%. So you go to the hospital, you are going to perform a surgery, and then the doctor tells you that there is a 95% that when you go for this surgery, you won't come back alive. Would you go and do it?
Not at all.
You won't do it. So significant testing is very important. That is why if you've ever done a surgery before, when they perform all the tests and then it defeats one of the statistical significance, it defeats one of the significant tests. If he will tell you that I cannot perform the test, so he will tell you go and come back. Because he will tell you that I can't perform the test, so go and what? Come back. Why? Because he knows that if he does that, somebody is sending, or some of us were misled to okay. Somebody sent a message. Sorry about that. So what you have to, Jeremy, sorry about that. So what you have to know is that these tests are done everywhere. When a medical doctor is going to perform a surgery, it ensures that all these tests are mentioned. The 95% significant level is met. Usually in the medical field, it is 99% or less. Why? Because it is human life. Maybe in Africa and in Ghana, it is not the case. But in Europe and the rest, I'll give my typical example. When I fell sick, they had to perform so many tests. Why? Because human life is very, very important. And then when you make the least mistake, your license is taken away. A friend of mine who was also there, he's now late. He went for driving test, and he always says that that is the only test he has failed in his life. He went for driving test and he failed because of this. And you know, when they go to school, after the school, you write exams, you go on the field, and they mark. And they use this to fail him because he didn't meet the 95% confidence. Why? Because they said if he give him the license and he drives, he might kill people on the road. So it is used everywhere. One of the key things you must know is if 95% confidence interval is 5%, what about 99%? What will it be? What will it be in terms of significance level? What will it be in terms of significance level? Anybody? Anybody?
Could it be 9%, please?
99%. So what will it be? You have
So I
tried,
think
but
it will be 1.
it's 1%. It's 1%. So you just subtract it from 100 and you get 1%. So you go there and say, there is a 95% chance that you would survive. Now, look at this. If you go to the hospital and they tell you, there's a 95% chance you survive, and then you go and then there's a 99% chance you survive. Which one will you prefer?
99%.
Which one will you prefer, please?
99.
99. So doctors and all these tests are performed. So please don't look beyond that. That's why we say 95% is what? Strong is statistical significant. 99 is what? Strong evidence of significance. Extremely strong evidence is what? 99.9%. And this is what my Chinese friend always tells me. I used to have a Chinese classmate, Shen Yu. His name is Shen Yu. He will tell me that whenever I do an estimation and I leave it at 1 decimal place, he says that it is not correct. The minimum is 4 decimal place. Why? Because if it is 1.11, 12, let's say 112, and I make it 1.1, there is 0.2 which is lost, and that is very significant. And I say it is not. It says use the Chinese population, and you understand. So we always target this one, the last one. The importance of the p-value, benchmark for most statistical, commonly used in SPSS, R, and other software. And then again, this is just a summary. Again, this is just a summary. A p-value is critical in hypothesis testing. Just a minute. Okay, so let's move on. P-value is very important in hypothesis testing and decision making. Now, another thing I want us to know is that data integrity and data type. Now, data is very important. Remember, I'll tell you one funny thing when we were students. When we were students and then we were employed by statistical service to go and then collect data. Statistical service to go and collect data. One of the things we did was some of my colleagues, not me, though I went to the field, they go and sit under the tree, or when they collect the data and it gets to a point, then the rest, they begin to fill it themselves. Remember, data must be up to date. It must be very reliable. And we doing that, we didn't understand the implication. So one of the recommendations we did, and that's what statistical service does now, is that they use a computerized system and then they collect the data. So in the computerized system, it takes into consideration your GPS address. So when you go there, you activate your GPS and then they're able to tell whether you really went to the household or not. And data must be of that integrity. So ladies and gentlemen, it is not just having the data, it is also ensuring that the data that you collected is very reliable. And this falls on both the employees and then line management. And then their responsibility is to maintain and ensure that that data is reliable, safe, the data is accurate enough. And to do that, you must always try to integrate the data. The data must have what we call a unique identifier. That is why all employees have ID. That is why when you go to the bank, you don't use your name. It asks you of your bank account. Before later, they ask you of your name. Now, I'll give you a typical example. So I went to Fidelity Bank. What's that? GT Bank to go and withdraw some money. That should be 4 years or 5 years ago. So when I went, what did I see? The lady said, are you not the person who just came to withdraw the money? I said, no. So the lady went into the system And then he said, okay. That was the first time I got to know there was somebody having my name. The person was also called Richard as well. The only difference is my middle name. So because of that, I started using my middle name. And the person was called Richard Asrabo. So I was also using Richard Asrabo. Now look at this. If the person is called Richard Asrabo and I'm called Richard Asrabo, imagine that there was no bank, there was no account number. What will happen? So we need employee ID so that it becomes a unique identifier. Everybody must have an identifier, and numbers are easier to identify than words. So to do that, we have data warehouses, we have databases, we have spreadsheets, the common one that you know, Excel. And then we have statistical softwares. The commonest of all is SPSS, which I teach at the undergraduate level. But there are key challenges when you are using these softwares, right? So why? Because data is becoming complex. There's the need for you to link data in various database, and all these challenges, right? All these challenges, right, have led us to where we need to use a very complex software for manipulation. And one of the key things, please, can you hear me?
Okay,
Please, can you hear me?
okay.
So there is a need to do manipulation. And what we are going to do today is basically start with the predictive modeling. Manipulate the data in the right sense. And to do that, we need how to handle data. We need to understand the statistical analysis and then what goes into model selection. Data as we have it, and probably these are the few slides I will say before we move to the practical. Data can be seen in two basic things. Either it is categorical or it is continuous. I repeat, data can be seen in two basic things. Either it is categorical or it is continuous. When data is in categories, we call it categorical data. And usually categorical data, when you are handling it, you cannot add them, you cannot subtract them, you cannot multiply them, and you cannot divide them. That is why it is strange. And if you've done that before, if you find the mean of gender or sex of an individual, sex is male, female. So how do you find the mean? That is why we don't find the mean of these gender. We find what? The frequency. And usually in statistical software, when you say mean, it will give you the frequency because these are categories. So please pay attention to them. Again, there are three types of categories or categorical data, right? Let me say that. So we have what we call binary, and that is what we are used to. You have it here, male, female. If it's training completion, yes, no, right? So something like that. Then we have nominal data. That one doesn't follow any category. For example, office location, Australia, Ashaman, Lebanon, Washington. You know, all those names are mentioned, they are in Ashaman Hill. So don't go looking at Europe. In Ashama, we have Washington, we have Lebanon, we have all that you can think of. Even Texas, we have them. So you can look at division. Is it sales? Is it HR? Is it finance? Right? Then we have the ordinal ones. And this is when the data is ordered or put in a rank form. For example, level of satisfaction, employee rank. Please remember, I said the categorical data, we have 3 types. Binary, yes or no. Nominal, no order at all. Then we have another one, which is what? Ordinal, which can audit. Strongly agree, disagree, among others. So this is it. Then continuous data. There are 2 main types of continuous data. There's what we call interval, and then there is what we call ratios. Now, please pay attention because this is where it becomes interesting. When we say intervals, these are data that are put in equal intervals, and they do not have no true 0 point. For this data, there is no, if there's a 0 there, it doesn't really have a meaning. For example, if I put the data there and then I put there 0 for age, what does that mean? There's no true meaning of 0 for age. There's no true meaning. There's no meaning for 0, right? So, for example, if I put 0 in front of age, what does it mean? 0 age, what does it mean? It'd be difficult for you to tell me. So these are called interval variables. Right? And for example, you cannot say 20 degrees Celsius is twice as hot as 10 degrees Celsius. Why? Because there's no absolute 0. You can have a 20 degrees Celsius in UK, which is hotter than a 30 degrees Celsius in Ghana. So these are important data that we must look at. Then there is the ones that we usually use. That is ratios. And the only difference between nominal interval data and ratio is that for interval data, there's no true 0. For ratios, there is a true 0. So for ratios, there's a true 0. So if you ask somebody of his salary and he tells you 0, it means he doesn't earn a salary. If you ask of my height and I tell you 107 centimeters, the 0 there has a meaning. And with this type of data, we can perform all arithmetic. We can add, we can subtract, we can multiply, we can divide. Unlike the interval and unlike the other categorical data that we have, the nominal, the ordered, and then the binary. So please understand the data before you handle the data. As an HR manager and as somebody who has to understand data sets, HR data set, you need to understand what type of data am I dealing with? What are the do's and don'ts with these data? And why do I perform what I need to perform? So I have given an example, enough of the example, binary, pregnant or not pregnant. You can't be in between, of course. Nominal, you can have divisions in terms of function, HR, rates, whatever. Ordinal, it's always used in a Likert scale. Satisfy, very satisfy, new, not satisfy, and the rest. Then interval, they don't have true zero. Ratios, they have true zero. So let's summarize the type of data. Let me just give you this very basic one and the mathematical operations that can be performed. So for example, if you have a binary data, male, female, yes, no, you cannot perform only serious predictive analytics there. Why? Because, I mean, male is male, female is female. You can't have middle way. You can, so nominal data is multiple choice category, no other. I give an example. You cannot perform any serious arithmetic. Ordinal data, you have it in ordered. You can order matter, but intervals are not equal. So that's another thing here. Then the intervals, equal intervals, no true zero. You cannot or can measure differences. Here, you can look at the differences, but not the ratios. So the ratios, intervals are equal. They have true zero. You can perform all arithmetic with ratio. That is why, as much as possible, we ask individuals that let's limit ourselves to the number of binary data we collect. Again, that is why we always say that one of the key things we need to do is that when you are doing an arithmetic, when you are doing an analysis, having a ratio data is the best. That is why I'll prefer you to give me your age in years than intervals. Because if you give me your age in years, I can find the log of it. I can add, subtract. I can do a lot of analysis with it. So ladies
Hello,
and gentlemen.
hello, Prof.
Yes, please. Yes, Dr. Reston.
If you can repeat that particular statement for them again, because they always present their results with age in categories, even though they could have collected them, the actual ages, and get the exact mean for us. So if you can recap that particular issue.
So please, as much as possible, let me go back. As much as possible, your age, right, should always be in years. Should be a continuous data so that you can, look, when you have a continuous data, you can find the mean of the age. When you have a continuous data, you can even later recategorize it using just a simple command to say, okay, put it in categories. But when you have a categorical data, you can't recategorize it. Or you can't make it into continuous. So there are some variables. That's why I always, sometimes people think that you want their salary. When you say salary, I always want to find the mean of it. So I like the continuous data. Please listen, because of the limitations of continuous data, it's always best. The limitation of categorical data is always best to get a ratio data. At least if you don't get at all, the last three is very, very important. That is why usually I, in particular, I hardly ask students to tell me a yes or no questions. Because yes or no is finished. You can't do anything. But even if I have an ordinal data, I can recategorize it into yes or no. But if I have a yes or no, I can't recategorize it to an sorry, if I have an ordinal data, I can recategorize it into yes or no. Because if you strongly agree, you agree. It can be equal to yes. And if you strongly disagree and you disagree, it can be equal to no. Then if you are in between, the data I can decide that I'm going to drop the in-betweens if there are not many. But if I have a yes or no, can I recategorize it into strongly agree, disagree? No. So as much as possible, when you are collecting the data, avoid too much binary category. At best, right? Fewer binary, fewer nominal. At worst case, if you can't get anything, ordinal, interval, ratios are the best. Ladies and gentlemen, enough of the data representation. Any question? Any question, please?
Hello,
Any
Prof.
question, please? Yes, sir.
Prof, good afternoon.
Good afternoon, sir. Please, how are you, sir?
I'm doing good, Prof. Hello.
Your question?
So
Yes, sir.
I just wanted you to give me
Oh, your
an
line.
example
I can hardly. Please, did anybody get the
of
question?
you are talking about age and years, and
Are we losing you? I think we are losing you.
yes, Prof. I was still talking. Maybe my
Uh,
line is not
yes,
stable.
your
Jermaine,
line.
please, is it possible you type it?
Okay, I'll do so.
Yeah,
Okay.
okay. Please do. Now, ladies and gentlemen, last thing before we start the practical is this. You need to. So, usually you see using group, teams level, or individual level data. Is there a difference between? So you see the choice between, so let's make a choice between a group, team, or team level, or individual level data set. In a team level analysis, where team means in a group level analysis, please pay attention. I'm not going to use a lot of group because I want us to move beyond the basic names to a more intuitive and common. In a team level analysis, one of the key things you would identify is that you use it when you are dealing with confidentiality. Anonymity must be maintained. Then you use a team level analysis. Right? So you use it to assess leadership effectiveness by evaluating team performance as a whole. That's a typical example of what you can use for a leading. Okay, so James says, Prof, can you give examples of the age and the years you talk about, please? Okay, so for example, I want to find out your age, present age. I'll just say age in the questionnaire, if it's questionnaire, age, and I'll put here, that's years. So it means that I want you to write your continuous age. Instead of age, then I'll put 20 to 30. No. I want the actual age. Right? Years in the organization. I want the actual years instead of giving you 2 to 5, 5 to 10. No, I want the actual years. That's why we do that. Okay. So if I'm doing something that has to do with confidentiality and anonymity, I will want to look at that. But if I'm doing something that has to do with examining personal attributes rather than team dynamics, then I'll do individual level analysis. So remember last week, I told you how to tease out a data from using R very easily. You can decide to tease out only for a particular individual. Once you know the individuals unique ID. Right. So you want to perform team level analysis and individual analysis. It depends. Usually in a sales issues are there, if there are various branches of an organization, they will do a team level analysis. But if it is only a department which is in charge of sales, then they would want to do individual level analysis. Right? So that you know which individual is performing better than the other. So those are some of the things. But again, ladies and gentlemen, there's a key word you must know: dependent and independent variable. Outcome and predictor variable. You hear it has so many names. Please go and look for the other names. The one name is outcome, which is the dependent variable, and a predictor is the independent variable. There are so many names. But when we say dependent variable, here we are looking at the outcome variable. I've even used the term. And this outcome variable is the one that we are going to predict or measure performance. So it means that the popular one, the effect of what? There's a popular HR topic that almost students will always want to do. Dr. Guesting can help me out.
Effect of motivation on employee performance.
Effect of, in fact, if
And I think a number of them might have already started working on this.
If I see that topic, I'll cancel the topic first. Everything effect of motivation. Then if they don't want, they will change effect of intrinsic motivation. Then once leadership X, Y, L. I mean, it's like
your X.
You see, that's the problem we have. We are not being dynamic. So it's becoming boring reading project work nowadays. And then the key one is big data. Right? So I ask you, what is big data? So please, when we are picking the topic, let's be very, very selective. It's not about it, but don't pick a topic that when you finish, you know that you have contributed to knowledge. And something that you can publish and be proud of. I'm working with one of my students on work he did, and he's so proud that, oh yes, I did this work, and that's stuff. And I'm like, well, yeah, you do something. It's not everything that everybody is doing. Then another thing is employee satisfaction. Plenty. So let me pick the issue: motivation on performance. What is the outcome variable? What is the outcome variable? What is the outcome variable? Betty, no, please, don't be laughing, because we need to understand the outcome variable is this: the variable that we want to predict. And for me, I would always tell you this: if you don't get a good outcome variable, then you have a big problem. So motivation on performance, it means we are looking at how your X variable is motivation, the Y variable is performance. I'll come and teach you how we get all that. Then the independent variable is what we call the factors that influence the right or change the dependent variable. And there are so many of it that you can consider. Now, please remember the type of statistical test that you are going to perform is dependent on your dependent variable. Largely rely on your dependent variable and not the independent variable. It's largely dependent on your dependent variable and not your independent variable. And students have very funny topics that they pick sometimes. Somebody is trying to do the something AI and technological performance. And I ask the person, can you measure technological performance? And then it becomes problematic. So please, I know you selected your topics, you are working on it, but just be cautious. Than that, you will get stuck. Now, you must also understand that your dependent variable is very important in selecting the distinct correct statistical approach. So if you have this, and it is key consideration, so I give an example, and I'm not going to read this, it is for you. I've talked about the dependent and then independent variable. I said it's called the outcome variable. It's also called the predictor variable, right? But it seems you know everybody's topic. So some people are doing techno stress. How are you going to measure techno stress, right? Are you using Likert scale? If you are looking Likert scale, what statistical analysis are you going to perform? All these things are very, very important. Again, the dependent variable is very key. And the predictor variable will influence the dependent variable in a way. It influences, it causes, it predicts changes in the dependent variable. So the independent variable you select is very key. It is not because you have looked at one study and the study has estimated this. So that is the case. And I always tell my colleagues who are HR managers that we must move beyond the simple descriptive and to do more complex and robust analysis, because where the world of work is going, HR managers must inform the policy direction when it comes to recruitment, right? So in a customer service study, for example, you can have your independent variable, customer service training, other things affecting the dependent variable. Now, key consideration, correlation, causality. And this is where I begin to cancel students' project work sometimes. There are two different things. There are two different things you must know. Okay, cause and effect relationship. Don't worry, that's where I'm coming to. Nana Iwa, thank you. I think some of you, if you look at what, for those I taught undergrad, they'll say that this man gives a lot of plenty work to do, but it's good. So look at this. What is the difference between correlation and causation? If there is a significant relationship between variables, does not imply causality. An example is this. If you consume high ice cream and you get skin cancer, it does not really mean there's a causality there. The real cause may be exposure to the sun. or it may be one-off scenario, right? So correlation is just saying there is a relationship or an association. Then there is an element of causality, where we say this causes this. And usually that's where we move into the arena of more of inferential statistics like the linear regression, multiple linear regression, the logic regression, right? If you are doing more complicated models, then you have others like the multinomial logics and all that. Those are what we use a lot. So please listen, let's go back to our basics. And I'll start with the basics, especially for the benefit of those I didn't teach in the undergrad, right? And for the new people, one of the key things you must know is that if your dependent variable is binary, nominal, ordinal, interval, ratio, there are different statistical analysis you must perform. If I see your dependent variable being binary and you are performing a linear regression model, then I say you have deviated 100%. So sometimes I always say when I go for presentation, I don't talk. Because when I see it,
Hello. Sorry, Doc. Prof.
yes, please.
Please, you broke off for a minute. I didn't hear what you were saying.
It depends. I'm saying that your dependent variable can be binary, ordinal, nominal, interval, ratio, and each of them have its unique analysis that can be performed. Each of them have unique analysis that can be performed. So, for instance, if your dependent variable is binary, you cannot perform a linear regression model. Never. And just as any software, some will give you warning and you will ignore it, but garbage in will always be garbage out. You having a result does not mean it is right. So please pay attention here. We've looked at the various types of categorical variable. For example, if it is one category, or if it is a continuous or mix, you can do a chi-square analysis, or you can do logic regression. There's more to it. And those I taught undergrad, they should be aware of chi-square analysis, right? It's not chi-square. I would come back and then take my time to explain each and every one of them. Again, so don't worry. These are all the analysis. So look at this. If your variable, right, dependent variable is binary, that's two-stage binary, right, or two groups, you perform what we call independent sample t-test. If it is binary and it is based on time, then you do pair sample t-test. I'll explain everything. If it is more than 2 or 3 plus, you do one-way ANOVA. If it is time-based, you do what we call repeated measure ANOVA. If it is one continuous, you do what we call the Pearson correlation or simple linear regression. If it is multiple continuous, you do multiple linear regression. And if it is mixed, you do a multiple linear regression with a dummy variable. Now, please pay attention here. I will come and take each of the tests one after the other, and then we will look at it. The question is, why is this important? As I move forward and as I explain, you will get the intuition behind why you must know this. Because a lot of time we perform nice analysis, but if the approach is wrong, the model approach is wrong, the estimation results can be right. But when you interpret it, it won't inform any policy. It will give you wrong policy implications. Very, very important. Okay. I have been talking for long. So we have also what we call parametric and non-parametric tests. All this will come and then take a look at it. Any question? It seems I've been talking for long. And all the tests that I mentioned, they are all here captured nicely for you. So don't worry. Cross tabulation, chi-square interpretation, and all that. I think we would give you this notes for you to have a look at it. And then any question? Any question? I would want to stop a lot with the theory here. Enough, too much of the theory will bore you. So next week, God willing, we can. Next week, I think it's in person, right? Please, it's next week
Yes,
in
Prof.
person.
Yes,
Yes,
Prof.
Yes, Prof.
Okay,
Yes,
so
please.
good. So next week we'll do a lot of work. Next week is going to be a lot of practicals. And please do not be surprised if I pull a surprise on you to write a quiz. So please do not be surprised. I have told you in advance.
Yes, Prof.
Yes, you might
No,
write a
no,
quiz.
Prof. No, Prof. Please
Yes.
say yes, Prof.
Hello, Betty. It's Patrick. Oh, it's Patrick. Learn.
So please, you would have the experience of that. So please, let's take note of that, right? So that we also want to have a feel of what we go through when we are teaching, whether you understand or not. So please, I'm going to end here, and then I will start with some of the practicals. Any questions, by the way? Okay, if there are no questions, ladies and gentlemen, I am going to conclude one aspect of it. Jifa, yes, your hand is up. I hope it's
Yes,
not about the
Prof.
quiz.
About the quiz,
Oh, no, Jifa.
no, it's not exactly about the
Aha,
quiz, but when you
thank
asked the
you.
question, I answered it in my head that we beg.
Jifa, I also beg.
But the reason why I raised my hand, Doc, please, we had a discussion regarding those who were having challenges with the R.
Yes, I'll
And
be there. I'll be there. I
you
haven't
say,
forgotten.
all right,
I'll be there.
okay.
Jifa, don't worry.
So
I
we stick
haven't
to the
forgotten.
time.
Yes,
Okay.
yes,
All
I'll be
right.
there. I'll be there
We
live and
we appreciate.
see, but don't be like the student that I had this morning. They made me not to go to church in the morning. Thinking we were going to have a class, only for me to call and then so many excuses. So please, if for
Colleague,
nothing at all, me, I want to go and sit in the church. I know I'm a sinner, so I pray that God forgives me my sin. Or I join my online church.
Mhm. Colleagues, please, in tree, they say, Ochiami oni masemka, osinana osempa.
Osempa, yes.
Mr. Sempa. Nana wasumua, okay, me that say.
So,
Nana wasumua, why, Mr. Mo colleagues?
so we have 30 minutes to close the class, and with the kind permission of Dr. Augustine and yourself, let's look at something. If you can see my screen, I am going to do data visualization. Why? Because all that we are saying, I need you to get the basics, because when I finish and we start doing next week, when we start taking the T test, we'll do all the 3 types of T tests within an hour. Then we'll move on to do ANOVA within an hour. So we'll do, and some of them we will plot some graphs for you to see. One of the key things I want you to understand is that, you see, when I was young, I used to like, it's not even right there. I used to be at Takrady. In fact, Takrady has been my base all this while. Yes, I was at that pipe, I know. I stayed there, family house. I have like 3 family houses in Takrady. And I used to like, is it a big crane? So yes. AB Cranston and CK Man, yes. See, when you go CK Man, he's sitting somewhere with his dot. And then he has some nice chair. He sits outside and he has his towel and be cleanly blowing the air. And then he sang that song, Me and my brand here. And those of you are old, you know. But there's something I want to say. He sang one of the song, this CK Man or AB Cranston. He said that, is it somebody who wanted to marry? And then he was in Europe. After enjoying his life, he was getting old. So they sent his youthful picture to a lady to go and marry. And then this man, after so many years in Europe, was coming down. And the lady thought he has gotten a European burger who is very nice, succulent gentleman. He only comes and realizes that the man was even with walking sticks. Those of you who are old, you remember this song. How many remember that song? You don't remember. I'll look for that song. Why am I saying this? I'm saying
Prof,
this.
please come again. Prof, please come again.
I was asking how many of you remember that song?
Prof, there's that song, please. Because I'm
Oh.
too old so that I'll recall.
The Akpacha and Agacha song, the one that he said, the guy was in Europe, he was getting old and he wanted to marry, and they took his youthful picture.
Maybe I was not born by then.
Oh, you were born. When I get you the song, you know. It's a nice song. So, why am I saying this? I am saying this because now they don't want us to know. Yeah, okay. I am saying this because one of the things you must know is a picture says 1,000 words. No wonder you ask the ladies when they are coming out, you look at how all the makeup in the world, if they had to use it to look beautiful, they would do. That is what visualization all does. Sometimes when you look at the things, you say, wow, right? So that is what data visualization is. We want to wow you with data. We want to see people look at it and then they are able to tell the story. And it is very easy to interpret the picture. When the lady is nice in the picture, she is nice. When she's not nice in the picture, she's not nice. True of us, the gentlemen. So why do we visualize? Simplify complex workforce data. Enhance data-driven decision. We want to communicate insight to non-technical stakeholders. We want to reveal trends, patterns, and outliers. Support predictive and strategic HRM. And then the last one is add more. So it means I've given you an assignment. An example of the data set we can have is all this. And I would give you a data set that has most of these things. In R, there are so many packages. I will introduce you to packages today, God willing. There are so many packages you use in R to draw graphs. And one of the best package is ggplot. This one, I will introduce you to it. It's one of the best packages to use to draw graphs. Talk about 3D, talk about mapping the earth. You can even use it. You can download coordinates data and all that and plot it. But of course, I don't usually do that because when you do that, students will complain. And this one there. And then we have interactive. It's called Shiny. Very, very interactive. It's an HR dashboard you can use to do a lot of interactive data. Those of you like pictures. For employee demographics, we'll use the bar. We can use pi for gender or education. We can use histogram. Now, please listen. Whenever age is a continuous data, you use histogram. Whenever age is a categorical data, you use bar charts. Very, very important. And we'll look at density plot. For example, salary distribution across gender, something like that. We can do turnover analysis visualization. Performance and training visualization. We'll do all that. We'll do the heat map, one of my favorites. The heat map, skill proficiency by department. One of my favorites is the heat. Then I'll do the radar too. I like it, but I'm not so fan of radar. That's when we are going to compare competency comparison. And then we can do the box plot. Ladies and gentlemen, we have a lot to do. Then when you have your Likert skill that you people like, you can do a Likert skill chart. Cloud computing, when you want feedbacks, teams. Dumpling bell or dump bell. I've never pronounced it dumbbell. I always pronounce it dumpling bell. I don't know why. When we want to do before and after satisfaction of something, right? Then we can do correlation metrics, which will come and do regression plot, which I will want to do. Decision tree, one of my favorite, the rock curves, very, very important. And then other interactive dashboard that we would want to do. We'll try our best to link, to get the data that links our visuals with the KPIs. So ladies and gentlemen, and to conclude this, the best practice of HR visualization is use simple, meaningful visuals. You label your axis and then your legend clearly. Use color consistency. Avoid distortions. Link visuals to what? HR objectives. So when you are typing your headings, you must look at that. When you are doing visual flows in R and in any other thing, you read your data. Remember, we've done how to read the data. When you import the data and all that, you clean your data. Right? Who was that? Somebody was, I've forgotten the name of the person. The one who called me over the week. Somebody, what's the name? You clean, you
Bridget.
summarize. Is who?
I told you, Bridget. My name is Bridget.
Yes, Bridget. Yes. How are you, by the way?
Oh, please, I'm doing fine. And
Thank
yourself?
God. I'm blessed. Thanks for asking.
Thank God.
Thank you. So we will look at visual patterns and then we will in interpretation and communicate the findings. Key takeaway, ladies and gentlemen. When you do visuals, you transform your HR data into actionable insight. Now, I've limited myself to HR data because I'm dealing with HR students, right? So you look at it, there are diverse tools. Choose visualization based on the HR questions you are asked. Sometimes when I go to the presentation and I look at the visuals, then I ask myself, what informed the choice of the visuals? Remember, you are using visuals to tell a story, and the story is based on evidence. And like the gentleman in the class, when you see a nice lady, you sharpen your words. Choose your words carefully. Maybe you are not Gen Z and the rest. But you see, you sharpen your words, you know how to, the first words to say. So please, let's look at that. So this is where I will end the theory about visualization. Ladies and gentlemen, let's start And I'm going to start with all that we have been doing. There's a hand up. Is there a hand up? Was there a hand up, please? Now, let's go back to the data that we have been. Oh, sorry. See, I do a lot of stuff, so sometimes forget about what you see here. Yes, this is what we did last week. So I am going to highlight everything and run the command. I can use source, or I can run one after the other, any which way I want to. You can use source. I like to run the source. Now, please listen. When you use the source and you have an error in the data, it might not finish running everything for you. So highlight everything, use source, and it will run all the data for you. Remember, I told you we are building on the data. So today, I am going to do data visualization. Please, if you are ready, let me know, because I'm starting. Can I move on? Have you all run it? Remember, let's put the dates there.
Hello, bro.
Yes, Madam Azir.
Good afternoon. Please, you were saying that if the last time you had an error when you're running it, you should press source.
No, I was saying that when you run the source, usually
Okay.
when you have an error, it will not finish reproducing the whole thing for you. So what I would advise you is highlight everything. And then when you highlight everything, you run it rather than using source. What's today's date? Today is 4th, right? Or 5th? No, today is 5th.
Okay.
Yes. Usually. So today is 5th. I want to keep.
October.
Oh, yes, October. Why am I sending us backwards? 5th October. Thank you. Seems. Did it right? Okay, beautiful. Let me even make it nicely. I like to, let me pick October. So let me just make a topic. Topic, data visualization. Nice. So, okay. So ladies and gentlemen, let's start. I want us to pair the data that we have. Pair the data that we have. And please, I have gone through the assignment you sent to me. Interesting. Most of you have virtually the same code. I don't know whether it was a group work you did or somebody did and was teaching others, but virtually the code were virtually the same. And funny enough, I won't mention names. Funny enough, some people had the same line. So if it is 4, if it is 9-4, all the analysis from 9-4, everything is the same. It was interesting, but I assume you did it as a group. So that's the feedback I got, but most of the results, things that I ran were okay. Now, we are going to use the Altera data. Now, in the Altera data set, That's what, if you see my screen, please look at it. See, all the data has been employed. Most of the things I was talking about, every employee must have an employee ID and all that. They are here, education and the rest. Now, let's start with the basic data analysis. I'm going to start with a simple bar chart. I'm going to start with a simple bar chart.
Hello,
Now,
Prof.
yes, please.
Okay, this Edith again. You know, where you type today's date and you started, I'm struggling to bring my cursor so that I can also try and follow up with you. I don't know how.
Maybe.
Okay.
We have
Prof.
done this journey before.
Please continue. I'll listen. Please continue.
Yes. So we'll find, I think Bridget had a similar issues the last time until
Okay.
we helped along the line. So please, don't
Okay,
worry.
Prof.
That's why next week, please, I'm going to make myself very much available,
Yes, please.
especially for this. Okay,
Yes, please. Thank you.
let's start with a simple. I'm going to do, there are two things I'll teach you. One is basically simple graph without packages. I'll explain what packages are. So I'm going to do a bar chart. Hey, what am I? A bar chart. Can I move on? Can I move on, please?
Yes, please, Prof.
So look at the data. What can we perform a bar chart with? I'm going to start with gender. I'm going to start with gender. Can you all see gender? Gender, you can see my gender is down here. Now, the word is bar plot. So when I type bar plot, it even came. Bar plot. What do I need for the bar plot? I'm going to say go to Altera. Remember, Altera is the name of the data set. Subset. What do I want? I want the bar plot for gender. So let me just make a bar plot. I'm going to put there 1, gender, right? So let me just enter it so that it will be a lot of space for those who do not. Now, I'm going to start with this. If I run this, it will give me an error, right? So what do I need? What do I need to do the bar plot? I also want you to look at this. Now, for the bar plot Altera, I need to continue by using the word main. Main in R is the title and the subtitle if I want. So main. So the main is just telling you what's the title name, what's the title of the bar that you want to plot. So I say bar plot of, yes, Jipa.
Prof, please, there's a symbol after the gender. Can you kindly tell what it is?
What's the symbol after the
At
gender?
first, I thought it was your cursor, but it moved.
Oh, it's
Okay.
a comma.
So that's the one moving around.
This one?
No, there's the one moving around, the one that you just moved down.
Which one is that?
You
That's the
just moved
cursor.
down.
Oh, this one.
Yeah.
Oh, it's my cursor.
Okay, so and the one blinking is what? The one after the male.
Oh, the one after the male is how do I call
Quotation. Quotation mark.
that? Thank
No,
you.
no, it's not that.
This one, the line.
The one blinking, yes.
Oh, it comes with my machine.
Okay.
In
Got
fact,
a little bit
it's a
of-
borrowed machine, by the way.
Okay. Thank you.
Yes. Yeah. Oh, okay. Oh, did I say? But so how do we call this? Gender distribution, right? Of distribution of the Atera data. Then again, I must give it a label. X label. My X label is my gender. I can give it a Y label. Y label is my count.
Elsa there.
What are they drink water?
I didn't hear Elsa.
Frozen Elsa.
And then I can decide to color it. You see, that's a short form of color. I can decide to color it. Let me put it in a very good this thing. What color? Males usually like, maybe males like sky blue, maybe sky. How do you spell sky at all? Is this correct? Sky blue? Yes, it's correct because it came by itself. Then females, females usually they like pink. True of us. I think so. The ladies, is it true? Then I can decide that, yes, Jipa, your hand is still up. I want a border.
Prof is
Yeah, yes, your
Sorry,
hand is, somebody's hand.
is the old hand, sorry.
Okay, somebody's hand is up. Somebody was speaking. I want the border to be white. Something like this. Something like this, right? Okay, so if you don't want me, let me do something because it's giving me a height of non-numeric argument for binary operator. So let me just do something little so that I don't have to go through. Are we good to go? Let me just do. Let me just do something. I want to do something. There, gender. Let me just generate something. Where is my support to table? There, gender. Okay. So I'm running this. Yeah, Gloria.
Prof, please, I want to find out. You said Atara gender. Is it underscore?
Yes, underscore.
Yes, please. Thank you.
I can even make it. Let me just. Should I take it out? Let me just take it out and see. Good. You can take it out.
Gender. Next.
Let me just change this and see why my machine is giving me errors. Good. Is to Basa. Can I move on? Please, can I move on?
Yes, Prof.
Hello. Apart from Betty, is everybody okay?
Yes,
Betty
please,
is okay.
Prof.
Betty seems okay. The rest of you, are you okay?
Yes, please,
Now,
Prof.
please see this. Have you seen where my cursor is? Zoom export, right? Oops. Yeesh. Probably goes off. Thank you. So you can zoom it, zoom out, and then it opens. Can you see my plot?
Yes, please.
Yeah, so you can zoom out and come. Later on, because today is a Thursday, later on, I'll show you how to reduce the plot size so that we can have it half, something like this, so that it doesn't become bigger like this. You can also export the data. You can save it in PDF. You can save it as an image, or you can clip it. Here, you can reduce the height. You can reduce, let's say, let me make it 400. And then let me make this 200, something like this, right? You can reduce it, you can increase it, update preview. And then you see when I change the preview, see how it has become. You can also increase it, excuse me, 500, and then 300. And then you can update, and then the preview will come. Later on, I'll teach you how to go about it. So don't worry. Now, one of the key things is that you see the data set. Why I had to use this is because, yes, Jipa.
Prof, please, a while ago, how did you get the charts? to move alone on the screen, like it separated itself, not exactly separating, but you had a drop of the chat and you were editing it. How did you get the job?
This one, Zoom.
Oh,
Not the Zoom we have been doing, no.
Okay.
I think she's referring to the export.
Oh, is
Yes,
it this
how you got it to?
this one? Oh,
Yeah.
okay. The clip.
Yes, yes, right. Okay.
Okay, this one.
Yes, please.
Okay.
Thank you. Okay, I got it.
Now, because the data is binary, and it's also because the data wasn't coded as a real binary, but came as nominal. That's how come I had to generate a table that counts the data set before you can do this. There are what we call packages that you can use without going through this long process. Today, I want us to do the manual stuff, and then later on, we can modify this, and then we'll see how it goes. Can I move on, please?
Yes, Prof.
Okay. Now, you see that this data set has this count and the rest. If you use the zoom, you zoom out, it has all these counts. In fact, because the gap between this, look at the female and the male is huge. We could have allowed it to use a certain, R would choose its own scale. We can decide that we want to unscale it to use our own scale. We'll come and do that later, right? Now, again, let's do similar for full-time, and then what's the name of that data? Whether the person is a full-timer, what is it? This data, full-time to part-time. Let's generate something for it. FT stroke, how do you call it? Stroke PT. Let's generate it. Who can help us generate it, or who has been able to generate it? We can copy this, right? And then just change the names. That's all. I'm going to copy, paste. I'm going to change it to FT stroke ET, right? Please hold on for me just a minute. Whilst you hold on, be doing it, you can change this count. Let me just use FT. Let me just change this to FT underscore PT. Count data. Let me count it. PT. Let me even, so I can change this. Come and copy it here. Just copy, paste. So we can do full FT stroke PT. So FT stroke PT. What color can we use? We can change this color to blue. And then we can change this color to what? To maybe yellow. And then let me use the borderline to be black. Black. Yep. Run it and let's see how it goes. Yeah, you go. Something like this. You can zoom it. You see it beautifully. Later on, I'll show you how to write a percentage inside a box. Please try your hands on them, right? These are basics. If that is the case, somebody, let's do that for department. Let's do that for department. Please, let's do that for department and see how it goes. Department has many variables, so will this work? I think recruitment channel is easier. Department, let me see the department. Yeah, department and recruitment channel. Please, let's do that. Department and recruitment channel. I thought I was talking. In fact, I was talking, thinking that didn't know I was muted. Sorry. Eugene, are you with me? I saw Eugene's comment. Now, please, have you done the others? Who has done the department? Just copy, paste, and change. Use different colors. It helps. So number 3, I want to do department. So let me do department. Oh, nice. How nice it is. Department. Now, please listen. When it comes to the department, we have so many. Let's see, how many departments do we have? So to know the number of departments we have, let me do this way. Let me show you something. Let me write first, know the number of departments we have. Right, so how do we do that? Tap was Terra department. Where's department? Hey, all these departments. How many? 1, 2, 3, 4, 5, 6, 8, 9. 9 departments. So we have to get 9 different colors. Are you with me, please?
Yes, Prof.
So I am colorblind. I only know the basic colors, so we can add the rest. So this one, what color should we use? Betty, you are the color person, so tell me what color we should use.
Red, Prof.
So Betty, we need 9 different colors. So the
Should
first
I
one,
give you all the 9?
give me as many as you can give me. So the first one is it should be red.
Yes.
Red,
Then
okay, comma. I'll keep my blue. I'll keep my yellow. What else again?
green,
Green. I'll keep my green. Okay, what else again?
brown,
Brown. Oh, I've forgotten that there was a color called brown. That's a human being's name. What else again?
pink,
Pink. Okay. Okay. What else again?
purple.
How do you spell that color?
P-U-R.
Aha. P-U-R. P like this. Okay,
Yes.
this is a color purple. Oh, and the summer ball.
Orange.
Yes, those colors those are common colors I should know, right? What's the difference between orange and yellow? Oh, okay. It looks brownish.
Right, a little.
1, 2, 3, 4, 5, 6, 7, 8. We are still
Left
one
with
color.
one.
Yeah, one more.
Black.
No,
Black.
black.
Gray.
We'll use black for the border. Which one?
Indigo. Indigo.
What color is indigo?
Let me see if there's a color like this. Indigo. Is it like this? There's no color like that. Oh, my spelling is wrong. How do you spell the indigo?
G-O.
Somebody is talking behind, but I don't know what the person is saying. Please tell me that. Even if the person is not part of the class, you should say it. He's enjoying the class. So let's move.
Taquet blue.
Pardon me?
Taquet blue.
How do you spell the colors? Please, look. I always tell people I don't know colors.
When you are mentioning the colors, please spell them. You said turquoise. Let's spell it.
Yes, spell it for me.
Let me spell it.
T-U-R.
Turquoise.
T-U-R. T-O-I.
P-O-I.
No. T.
T-O-I.
No. T-U-R-Q. Q-U-O-I-S-E.
U-O-I-S-E. Oh, this color.
Yes.
But this color looks like, what color is this? It
It
looks
looks a bit like green.
Yeah, taquet blue.
Are you people? Me, I go with my usual colors. Red, blue, yellow, green, brown. Those ones I know.
Yeah, primary colors, baby.
I don't know. Turquoise blue. I think I use this. I use this thing. Problem. The gentlemen. See, the gentlemen were not talking about the colors. The ladies were giving us the colors. Yes, this is something like this department. So I'll later show you how to put the figures there. So with this, you can easily see the department which is doing. Which department is that? You can bolding it. If you zoom in, bolding it, it will come clearer. You see how it is? It looks nicer. Right? Something like this. It looks. Yeah, so you can have a color like this. I mean, this department, sales is doing quite well. A lot of people are sales. So ladies and gentlemen, you can try your hands on them. See, that's why I say data visualization is very catchy. With it, you can easily explain. What if... Any question? Any question?
Prof, I think I observed something.
Yes, mademoiselle.
Please, when you are typing out the colors and you use the initial caps, the color will not pop up until you use lowercase
Yes,
color
it's
words.
lowercase.
Okay.
Yes, so you don't type the color starting with caps. You start with lowercase.
Okay.
Yeah,
Thank
you're welcome. So with this, it's easier, right? Somebody should, now not somebody, all of you should try your hands on, no, I won't say location. Location is too much. We should try our hands on, what else again? What else again? Recruitment channel. We should do that and let's see. Please, are you working on the colors? Later on, we would look at the various, what else again? Now let's look at histogram. That's virtually the last we'll do for today. And then we'll close. Is that salary? Let's look at length. We'll do the histogram for length of service. Okay. So histogram for length of service. So are you ready for the histogram?
Energy for please, Prof.
Okay. In a jiffy? Yes, in a jiffy. Have you done the recruitment channel? Can I move on? Hey, please say something. Length of service, right? I've generated my histogram. Once it's a continuous data, it's easier. Please, can I move on? Hello.
Hi, Prof. Please, you can.
Oh, yes, histogram. So this is a short form for histogram is his, right? Like history. So histogram, and then you type in that. But this doesn't give you a lot of detailed stuff. So to get detailed stuff, you need to add more to it. And then how best to add more? Than to copy whatever we have done and then paste it. So copy whatever we have done from there, from the main, right? So you copy from the main, histogram, this, you copy from the main, color, and then up to border. But remember, in the histogram, it's only one color, so you don't. So histogram is only one color. Give me a color that I don't know, that I can spell.
Tan.
Which one is that? Tank.
Tan. Tan.
Hey, is that a color?
Yes.
TAN. Let me see if I can recognize that color. Tan. TAN. Oh, it's a color. Is it brown? It looks brownish, right? So my X is just, the length of service. Length of service. My Y is my frequency. Let's make it frequency. Tan. Oh, okay. I didn't know there was a color like that. So let's see. Oh, okay. Doesn't look bad. So majority of the individuals be aligned here, they've gone for 3 training or 2 training. So do that for age. Let's see. Oh, okay. Emmanuel, you've copied everything. Okay, that's nice, Emmanuel. Years of service, length. Okay, years of service, Emma has made it years of service. Lab is Y should be number of employees. It should be the frequency. You use light green and white border. Not bad. Let me copy what Iman. But you didn't close your bracket, so it will be difficult running. So close the bracket. Oh, white border, after white border, I think you can close it. No, it mean 9.7 space. Okay, let me run your command and see. You need to close the brackets. Yeah, green. Doesn't look bad. So please try your hands on it. Now, please look at this. You see this arrow? Can you all see?
Yes,
Hello?
Prof.
Yes,
Yes.
just click on it.
Yes.
Once you click on it, it sends you back to all the graphs that you have done. You don't need to rerun all the graphs again. It saves it for you. So you can decide that, okay, I want to copy it or do whatever you want to do. You can publish it, but we will not do, I'll teach you more about the publish plots later. So this is how it goes. What about if you want to do the last? Are we good to go, please? Okay.
Yes.
So my work for today has been done. We started off with just we've done the theory. Now you understand the data properly. We've done a little bit about the plot. We'll continue with the various plots. Please try your hands on them. You have a lot of the data sets here. Just copy paste, change one or two things, and then see how it reflects. I want some of you to look at education. I want some of you to look at previous year rating, length of service we've done, if the people met the KPI or not. You can look at that, run the graphs, and let's see how it goes. When we meet next time, we would do a lot of, we'll start with, testing the hypothesis, the t-test and all that. When we are done, we'll go back and relax with the graphs at the tail end. Okay, so if there's no question, I want to end here. I am done for the day. Dr. Augustine, over to you,
Hello.
please.
Okay.
Hello, Prof.
Yes, please.
Before you go, can you please kindly post the prompt
Okay.
in the chat
Today,
for us? Thank you.
for today.
Yes, yes, please.
Okay, so this is how. So I have dropped it. So I've dropped it in the chat. Okay, Dr. Augustine, please, over to you.
Okay, Prof. Concerning the quiz we did last Wednesday, I got the feedback that a number of you encountered some challenges. So for that reason, we are going to provide an opportunity this Wednesday for another option. So those of you that were not able to make use of the first option, this is another opportunity for you. This coming Wednesday at the same time. Again, the theories that we did today, the slides will be shared. Please start working on them, reading them, so that the other subsequent quizzes that will be made available on the LMS, you'll be able to excel in it. Okay, if there are no other issues.
Dr. Augustine.
Yeah, Betty.
Please, concerning the quiz time, we'll please plead with you and Professor Travel, if you can make it open for probably from the 7 to 12, because part of the reason why some faced challenges was because of the timing. Some were in traffic, some